Continue from previous video where we calculate the internal axial force due to virtual load. Now we need to calculate the internal axial force due to the real load, so we can draw the same truss systems here with the vertical loads, let's say pin supports here, and we have vertical loads given at point number we have vertical loads given at point B, which is 100 kilonewtons, and we have a C and D, and we have this measurement 2 meters, and this is 2 meters and 2 meters. Now we're going to solve the same. We're going to solve for the same. We're going to use the joint methods. Let's take the joint B first. Now these joints I can redraw it here, which has a force 100 kilonewton going down. We have joint B, and this is force FBA, and that is force FBC, and we have 2 meter square root 8. Now for here, let's take the sum of the force in the y direction. Upward is positive. In this case, minus 100 kilonewton going down, which is this one, and this force need to have a vertical component, which is FBC times 2 on square root 8. This is vertical 2 and diagonal square root 8. So, and that is going up, and that is going up. So plus FBC times 2 on square root 8 equal to 0. We can FBC, we can bring 100 across, 100 kilonewton, and we can just times by square root 8 on 2. That's give us the value of 141.4 kilonewtons. So that is FBC. Now we can apply sum of the force in the x direction equal to 0. Left to right is positive, so FBA is negative because it's going left side. And then if I take the horizontal component, then it would be left FBC 2 on square root 8. This is the horizontal 2 and this is diagonal. So that is again FBC times 2 on square root 8 equal to 0. Now we substitute FBC in here. So FBA minus FBC, we will substitute 100 on 2. So that is FBC multiplied by 2 on square root 8 equal to 0. We cancel 2 square root 8. So FBA minus 100 equal to 0. So minus FBA equal to positive 100. So FBA equal to minus 100 kilonewton. So we found two forces, FBC equal to 141 and FBA 100. So let me put that one here. FBC 141.4 kilonewton positive, and we found minus 100 for FBA. So that is two forces that we found. Now let's continue. Let's take the joint C. If I draw the joint C here, we have this force. We have third force is going horizontal in here, and that is FCD. Let's say this is point C. We have this force. Now this force is 141.4 positive, so 141.4 kilonewton, and we have 2 square root 8, and that force is FCA. Now we have two unknown forces that we need to calculate. Before that, we can just simplify this one into horizontal and vertical component, and here as well we have 2 square root 8. So this is FCD, and for this force FCA, we could have a FCA times 2 on square root 8, and we have FCA 2 times 2 on square root 8. And for this force, we would have a 141.4 kilonewtons times 2 on square root 8, that is give us 100 kilonewton, and it also give you downward minus 100 kilonewton. Just make it plus, right? Because if you multiply 141.4 again here, kilonewton times by 2 on square root 8, it gives 100 kilonewton. So now it would be more simple. I remove all the diagonal forces. So let's say sum of the force in the y direction equal to 0, upward is positive. Then we have this FCA going down, so FCA times 2 on square root 8, and we have this 100 kilonewton going down, so minus 100 kilonewton equal to 0, minus FCA times 2 on square root 8 equal to positive 100 kilonewton, minus FCA equal to 100 times square root 8 on 2, that gives us 141.4 kilonewton. So finally FCA equal to minus 141.4 kilonewtons, right? So that is the third force. And we can apply some of the force in the x direction equal to 0, left to right is positive, so we have this FCD and we have this FCA and we have 100 kilonewton. So FCD is minus, this force FCA component as well minus FCA times 2 on square root 8, and the third one we have positive 100, kilonewton equal to 0. So minus FCD minus FCA, we need to substitute this value, minus 144.4 times 2 on square root 8 plus 100 kilonewton equal to 0. Now here minus FCD minus is plus, 141 times 2 give you 100 kilonewton plus 100 kilonewton equal to 0. So minus FCD plus 200 kilonewton equal to 0, give you minus FCD equal to minus 200 kilonewton. So give you FCD equal to 200 kilonewton. So now we found all the forces required to calculate the deflection. So let's take the fourth step. Let's say step number 4, we need to find deflection at point C. To calculate this one, we have an equations from the virtual work method that the deflection at C, let's say in y directions, that N, capital N L over EA. Now this has to have number of values, because we can't, we need to break it down into number of members. So let's write it down, N1 capital N1 L EA E1 A1 plus N2 A2 L2 over E2 A2. How many members we have? We have let's say member 1, member 2, member 3, member 4. So we need to get the 4 different components. So N3 capital N3 L3 E3 A3 plus last one N4 capital N4 L4 over E4 A4. Now N1, we can go back here, we can list the please note this one has a, let's give the name, let's say this is 1, this is 2, this one 3 and 4. So 1 is N1 equal to 0, N2 equal to 0, N3 equal to minus 141, small N4 equal to 1. So this is the value we're going to take. So 0 0 minus 141 and 1. So over here, if I substitute 0 here, 0 here, and if I substitute third one minus 141, and if I substitute this one 1, then these terms would be 0 because multiplication is 0. So I need to substitute. So over here I just need to substitute for the 3 value. Now let's substitute the value. N1 is minus 141, capital N3. Now the third component is AC. So FAC is minus 141.4. So minus 141.4 kilonewton times AC has a length. So if you come here, AC has this length is a square root 8, Pythagoras theorem. So we substitute square root AC, L3 is 8, I'm talking about here, and E over A is given 80,000 in the example, plus N4. N4 is last one, which is 1 small n. Capital N4 is the CD, which is 200, so that is 200. L4 equal to 2 meters over 80,000. So if you simplify this one, it gives us 564 over 80,000 plus 400 over 80,000, which gives us 469 over 80,000. And if you take this, this gives us 0.012 meter, and if you multiply by 1000, then it gives us 12.05 millimeters. So delta in the delta C in the downward directions, it is 12.05 millimeter. Thank you very much.